Wait till it tells me I'm recording. All right. So again, we're doing scientific notation. We're looking at kind of, because in physics, we're going to deal with very, very small numbers and very, very big numbers. And in fact, that's what scientific notation is all about. Scientific notation is used to represent very, very, through two of them in there, because it is very large numbers or very, very small numbers. All right. And so, for instance, in a large number, we could get something like the speed of light. Now, the speed of light is 300 million meters per second. So we can all agree that's pretty fast. You're going 300 million meters per second. In fact, you can probably get around the world in about a second and a half if you go across the equator. Now, here's the thing is we're going to write this in scientific notation. Now, when you write a number in scientific notation, you always have a decimal, all right? And then you have one number left of the decimal. Now, the thing about the number in front of the decimal, it can never be zero. Anything but zero, but you got to have one number. And so right now, our decimal is right here at the end. Even though you can't see it, it's there. And I'm going to move it. And so I'm going to move this decimal till I get to the point where there is only one number left of the decimal. So when I kept moving it, I eventually get it between that 3 and that last 0. And so the number I'm going to have here is 3.0. All right? So I've got one number left of the decimal. Then scientific notation, just the way it looks, I'm going to get times 10 to the power of a number. And what I look at is, how many places did I move? Well, I went 1, 2, 3, 4, 5, 6, 7, 8 places is how many times I moved that decimal. And so this is the number of times the decimal moved. All right, because again, I got to move it until there's one number left of the decimal. I move that decimal 8 times this way. So I got a decimal between the 3 and the 0. And so I go 3.0 times 10 to the power of 8. All right, now an example of a small number. Small numbers. How about, I'd like to stay with the old science here. The human red blood cell, which we all got, has a diameter, so the distance across it, all right, of this 0.00, make that decimal big there, 0.0079 centimeters. All right, so again, I want to put this in scientific notation. So what I need to do is move that decimal, because you can actually see it this time, and so that I keep moving it until there's one number left of it that isn't 0. All right, so look at it. I move it here. I go, move it, move it, move it, move it, move it. Bingo, right there. When I move it, it's between the 7 and the 9 that's going to happen. And so in scientific notation, I'm going to write down 7.9, and then I'm going to have times 10. All right, now I got to figure out how many places I move this decimal. And so I moved it once, twice, 3, 4, 5, 6 times. So I put a 6 here. Now, here's the catch. I'm going to change that 6 just a little bit. I'm going to make it a -6. Now, here's why. Because when you're dealing with large numbers, you got a positive exponent. And so that's with our speed of light there. That's a big number, large number. We've got a positive exponent. And the opposite is true. When you're dealing with these really small numbers, go the opposite way. It's going to be a negative exponent. All
Like
right.
when it starts off as a small number, right?
What's that, sorry?
Like when it starts off as a small number?
Starts off as a small number. That means the exponent's going to be negative.
All right, got it.
Somebody always asks me, what's a large number? What's a small number? Something bigger than 1, that's a large number. Something lower than 1, that's a small number. But essentially, when we're doing our calculations, the number's either going to be really, really big or really, really small. Because what's, like, again, why we're doing this is because on your calculator, some people can't read it. So if the number's too big or too small to put on your calculator's going to pump out scientific notation on you. So you got to know what you're looking at. All right, now, how can we convert them? Because you get one of those things on your calculator. You got to be able to write it down. And we're going to actually go through kind of what your calculator could look like for a few of you.
At least you actually have a whiteboard.
Yeah, oh yeah, I got both. I do presentations and whiteboards.
I wish my math teacher had a whiteboard.
Who'd you have?
Oh, I forget her name. It wasn't last quad, so my memory's kind of foggy on what her name was. I have to try to remember. Actually, I can go look at my class history. Hold on.
No.
Was it Miss O'Donoghue?
Yeah. Miss O'Donoghue. That's who it was.
Yeah, I had her too.
Yeah, she doesn't mess around.
Who said that? Elijah?
I did.
Oh,
All right.
Oh.
Write the following in scientific notation. All right, so here's where I get a number and I got to put it in scientific notation. Now, the reason we're doing this is because sometimes your textbook will give it to you in scientific notation, or you'll have an answer and they put it in scientific notation. So you got to be able to compare, because some people will be like, I didn't get it right. No, you did. They wrote it as scientific notation. You didn't. For tests and quizzes, I just want the number. I don't care about scientific. I don't need scientific notation unless the answer is that big. All right, so we get something like this: 0.00018. All right. I'm going to flip that into scientific notation. I'm going to do the same thing here. I'm going to write down a few of them here. Let's go with 2,570,000. So that's a big number. C here, we'll go with, oh boy, what do we got here? 0.00. Better make these decimals big because I know you guys are, so you can see them. All right, so let's see. Let's fire down a bunch of zeros here. Let's see, nine zeros, in fact, and then we'll go 4. All right, and then D, we got 1, 2, 3, 0, 7, 0, 1, 0. There we go. All right, get that. All right, so we're going to flip all these numbers into scientific notation. All right, so the first one, again, I got to move the decimal, right, so that there's only one number left of the decimal that isn't 0. 0 don't count. So I'm going to move, still happening, right there, between the 1 and the 8. All right, so I'm going to write down 1.8. That's my number. And then I got times 10 because we're doing this in scientific notation. All right, and then I just, again, count how many spots did I move. And the reason I do these little move things is because it makes it easier for me to count how many I've moved. And so I go 1, 2, 3, 4, 5. So the number's 5. Then I look, is it a small number or is it a big number, right? Because that's going to decide whether that exponent there is going to be positive or negative. And if I have 0.000018, that's definitely lower than 1. So it's a -5. All right, now, here's the other thing, is that we get to B. Again, I got it to 2,570,000. So again, I'm going to move my decimal. So it's at the end, right, when it's a whole number. Going to move, and stop right there between the 2 and the 5. And so I'm going to write down 2.57. So if there is 2 numbers after the decimal, you write them down. All right, so then I got times 10. And then I see how much it moved. Again, I'm just counting my movements. So I got 1, 2, 3, 4, 5, 6 of them.
Question.
Sure.
Do you just always put the decimal like beside the first number always, or like does it vary?
Well, I put it in. I move it so that there's only one number left of the decimal. So in this case, when they're big numbers, yeah, you're just going to put it behind the first number.
All right.
Yeah. All right. And well, clearly 2,570,000 is a big number. And so that's going to be a positive 6. We'll leave it there. All right. So then I get this one. 0.0000. I could just say it. I'm going to probably miss one, but that's a big number. All right. Sorry, not a big number, but a size-wise, I guess it is. So I'm going to move this decimal. Got to move it this way to get one number left of the decimal. Move, 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 move. I keep moving. And of course, I get between the two 4s. All right, so my number I'm going to write down here is 4.4. Again, times 10. Figure out how much I moved it. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll throw a 10 down there. Again, I got to look at, is this a big number or a small number? Well, clearly it's a very, very small number when you got 0.00000. This is a number that wouldn't fit on your calculator. And so I put a minus sign in front of my 10 there. So I got 4.4 times 10 to the negative 10. All right, then last one here. Again, we got, what is it here? I'm going to put my little commas in there. Old school. 12,307,010. All right, so again, I'm going to move my decimal. It's at the end here. Move, 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 and move again. And as you mentioned, yeah, it's right behind the first number, right? But I still just move it so I can count those little things I got going on. Now, so when I write the number, I'm going to write 1 point, and I'm going to go, well, there's two numbers after that decimal, 1.23 times 10 to the power of, well, we'll figure that part out. Now, the reason I'm only going to two decimals is because really, when we're dealing with a number that big, the rest don't really matter, relatively, right? If I got $12 million, do I really care about the rest here, the 7,010? Sure, you care a little bit, but really not that much. Someone's going to give me $12 million. I'm not worried about $10 at the end here. All right, so then again, I'm going to count 1, 2, 3, 4, 5, 6, 7 times I moved. And again, it is a massive number, 12 million. So I leave it as a positive exponent. All right, so that is taking our numbers, our answers, and then flipping it into scientific notation, which you might have to do if you're checking in an answer in the back of the book. And they've got it in scientific notation, but yet you have it as a normal number. So you just want to make sure you're doing it right.
I got one last question. I'm sorry.
Sure.
Let's say there's more than two numbers to the right of the decimal. Do you include them?
Only need two.
Okay.
Yeah, only need two. Always to two decimal places. That's something we will talk about more and more as the course goes on. Two decimal places, because the reason I only need two decimal places, not only because some students like to round up, round down, is because everything that's in our life, the two things we use always in our life go down to two decimal places. Anybody know what those two things are that we deal with every single day that go to two decimal places? One of them for sure is you use every day. Time and
money.
Time and money. Time and money, always two decimal places, right? All right, so last one here. Example 2, like I said, we're going the other way. All right, write as a numeral or a number, same thing. All right, so we're going to take some scientific notation, flip it into a normal number. So we get something like this, 6.4 times 10 to the negative 3. All right, and B, I got a few, 4 of them here. 7.5 times 10 to the 4th. All right, and C, we're going to do 2.7 times 10 to the negative 5. And D, 3.8 times 10 to the power 6. All right, now, couple of things. We got to work with the exponent. Again, there's a difference between positive and negative because the negative, again, this is going to mean it's a small number, and the positive exponents means we're going to get a big number. All right, now here's the key or the trick is that with positive exponents, our decimal moves right. And guess what? The opposite is true. So if I have a negative exponent, the decimal moves left. All right, so here we go. I get the first one here, 6.4 times 10 to the power of negative 3. Negative exponent. It's going to move left, the decimal is. So here's what I'm going to do. I'm going to take this 6 and this 4. I'm going to write them over on the right side here. Because that decimal's headed left. Now, that decimal starts in between the 6 and the 4. It's negative. The exponent's negative, so it's going to move, the decimal's going to move left, and it's going to move 3 places left because it's a negative 3. All right, so I'm not going to put a decimal in between the 6 and the 4, but that's where it is now. I'm going to put 1 spot, 2 spot, 3 spot. I'm going to put a big decimal there. Well, what am I going to fill in the empty spaces with? Zeros. There we go. So 6.4 times 10 to the negative 3. Yeah, it's a small number. It's 0.0064. All right, now B, go the opposite way. We have a positive exponent. Means our decimal is going to move to the right. So I'm going to need some room out to the right here. So I'm going to take my 7.5. I'm going to write 7.5 here. My decimal is going to move 4 to the right. So again, the decimal started in between the 7 and the 5. So move once, move twice, 3 times, 4. And again, that's why I do these little loops, because now I just know wherever there's a space there, there's my zeros go. And so 7.5 times 10 to the power of 4 is 75,000. All right.
Wait,
now,
I thought we needed. When we need 4 zeros, or
no, because I moved 3 spots. That counted for 3 zeros, but then I had to move past the 5. So there's my 4 moves.
oh,
Yeah.
okay.
Because I had to jump past the 5, and then the other jumps create the zeros.
Okay.
Just like in the first one here, when I had a negative 3, I had to jump past the 6. That's one move, and then the other 2 moves gave me zeros. So even though it was 3, there was 2 zeros, because really the one in front of your decimal doesn't count, right?
Yeah.
All right, so same idea here in C. 2.7 times 10 to the negative 5. Negative exponent, it's going to move left. So I'm going to write the 2 and the 7 over here somewhere. All right, now it's going to move 5 places left. And again, the decimal is in between the 2 and the 7. So it jumps 1 past the 2. All right, then I'm going to do 2, 3, 4, 5. There we go. And so I've got my spots here. Put a 0 there, a 0 there, a 0 there, a 0 there. And of course, we always just put a 0 in front of the decimal. And so we get 0.000027. All right. And last one here. 3.8 to the times 10 to the power of 6. Again, it's a positive exponent, so it's going to, the decimal is going to move to the right. All right, so I'm going to put my 3 and my 8 right here. And then I'm going to move 6 spots to the right. So it starts in between the 3 and the 8. 1 spot, 2, 3, 4, 5, and 6. So I'm going to end up with 1, 2, 3, 4, 5 zeros because I had to take 1 spot to jump past the 8. And there we go. And so 3.8 times 10 to the power of 6 is, let's see here. I'm going to probably just write that number out. 380,000. There we go. All right, now here's something I want you to try. If you got a calculator in your hands, you have a calculator in your hands.
I'm grabbing mine right now.
Having it right now. All right, so because now here's the thing: is your calculators can show this stuff differently. All right, that's the hard part. It's all your usually when I'm in class, I can just tell you which type yours is. So I don't know. I'm gonna make something up here. Let's put in all nines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 nines. Yeah, 10 nines in my calculator. All right, so I'm going to take 10 nines. I'm just pumping that in. So 9 times 9, 9, 9, 9, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then I'm just going to times it by 10 fours. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I'm just going to multiply those numbers. That's all I'm doing because it's going to give it to me in scientific notation, and I just want to go through to you what it's going to look like. So, all right. So here's what I'm getting for an answer. Oh, that's wild. 4.44 times 10 to the power of 19. That's the answer I got. All right.
I got 4.44 times 10 to the power of 18.
Yeah, maybe your calculator only has 9 decimals instead of 10. Most of them are 9. I don't know why mine's 10. I don't know. I couldn't have left it on my floor.
I'm gonna try that one more time. It's 9 nines 10.
How's this? That doesn't matter. I'm not worried about. I'm worried about you reading the answer. I'm not worried about the numerical answer because some of you can get this. You'll get like 4.44, and then there'll be like 19 over on the side. I've seen that.
Oh, okay.
Okay, that's all I'm going for. Or somebody might get this 4.44 E19. What else do I get? 4.44 with like a little 10 and maybe a 19 down the bottom. Lots of different variations there.
So would you just kind of like know what we're talking about? Because like on a test, I mean like.
No, that's what I'm trying to get you to look at your calculator and you know what it's talking about.
Oh, okay. I just meant like on a test and stuff. Like if you saw like different answers for like one question, right?
Yeah, but if you write 4.4 E19, this doesn't really work.
Yeah.
Yeah. So you got to know that 4.44 say E19 if you have that, or 4.44 space 19. Like I've had students, if they got this answer, they would take 4.44 and not multiply it by 19 and then give me that answer. Stuff like that.
Yeah.
So I'm just making sure you know if you get this answer, what does it look like in your calculator?
Okay.
That's all I'm trying to get through. Because again, this